Hey guys, it's Mary and welcome back to Study Journey. I'm back with another AMC 12 Problem of the Week video. And to be honest, this is one of the hardest problems I've ever done. And this is using Euler's formula. So without further ado, let's get on with the video. This is AMC 12A Problem 13 of the year 2021. Of the following complex number z, which one has the property that z to the fifth power has the greatest real part? And then here are your answer choices. So the key words here are that it is a complex number. So that means it has an imaginary part. And then it is asking you which one to the fifth power has the greatest real part out of these answer choices. So the first thing we need to understand is Euler's formula to solve this problem. So basically what Euler's formula describes is that it describes two equal ways to move in a circle. So what this means is that here is the formula for Euler's formula, and then it is saying e to the raised to the I, which is the imaginary, the square root of -1, theta, is equal to cosine theta plus I times sine theta. So basically what we always do when we are looking with imaginary things is that we can put it on a coordinate plane. And this is obviously imaginary because you can't have an imaginary number on an actual plane, but we can use this to solve problems. So here is my x-axis and y-axis, and cosine, like always, is the x value, and the sine is the y value. But here, sine is times I, so this is an imaginary y value. Now, this point right here is a cosine theta plus I times sine theta, which is right here. And this point right here is equal to the rotation of when you put these two and then you rotate it up here. And you can also view it as the x, go over x and then go up y. So basically, imaginary exponential growth continually rotates. So unlike exponential growth, which always increases like this, an imaginary exponential growth would rotate this way. And so when you're raising it to a certain power, it's not going to always go up, but rather around in a circle. Now that we know this, we can use this to solve the problem. So the answer choices were -2, and then negative the square root of 3 plus I. So we're going to take B, for example, which is the negative square root of 3 plus I. So how will we solve this? Well, to find the real part, we can find the equation that simplifies to this, and then raise it to the fifth power to find that. So what does this look like? So this diagram is basically, here's the coordinate plane, and then you go over -3, because one of the other formulas we must know is that a complex number can always be written as A plus bi, where a and b are real numbers, and this part is imaginary part because it contains the I. So basically right here in this diagram, we can see that we go left negative square root of 3. So let's just say this is negative square root of 3, and then you go up how much, which is 1, well, I is basically 1 times I, so you're going up 1. So it will look like this. Now, we know that in a right triangle right here, this is going to be 1, right? And then if this is 1 and this is a square root of 3, then we know that the radius is going to be 2. So looking at this, we can see that this angle right here is going to be pi over 6. And that means what we are left over right here, which is the angle that is going to, this is going to be 5 pi over 6. In this equation, this point right here is rotated from right here to right here, which is going to be 5 pi over 6. So we can plug this into this equation. So it is going to be e to the I times 5 pi over 6, because this is the angle, is equal to cosine of 5 pi over 6 plus I times sine of 5 pi over 6. Now, since we are raising this to the fifth power, because it is asking you which one has z to the fifth power has the greatest real part, then when we raise this to the fifth power, we have to first multiply this whole thing by the radius, which is 2, because right now it is just in the unit circle where the radius is 1. 2 times e to the I of 5 pi over 6 raised to the fifth power. And this is going to equal 2 to the fifth power, and then ei to the 25 over 6 power. Now, 25 pi over 6 Remember, when we are in a circle and we're looking right here, we can see that one rotation is going to be 2 pi. So if you add 2 pi to anything, it is going to be equal to the same angle. It is just another rotation. So this can be simplified down to 24 pi over 6 plus pi over 6. So 24 pi over 6 is 4 pi and then plus pi over 6. So this basically means that you rotated it twice before going pi over 6 places. So technically, we can simplify this angle right here to pi over 6, since these are equal. Now, looking at this, we can simplify this with using the Euler's formula right here. So this will simplify down even more, and it would just be 2 to the 5th power times cosine of pi over 6 plus I sine of pi over 6. Now we know pi over 6 is 30 degrees, so cosine, which is the x value, or the x-axis value right here, is going to be the square root of 3 over 2. So this will simplify down to, and then the sine of that will be the y value, which is 1/2. Remember that it is asking you for the real part. So to find the real number value, we can just multiply this times the real number value, because this part, anything times that, if this is a real number, it is going to be imaginary. So we just had to focus on right here. 2 to the 5th power is 32 times the square root of 3 over 2, then that would equal the 16 times the square root of 3, and this is the real part. So looking at just b in general, we can see that to find the real part, you just multiply the radius to the 5th power, and then you find the cosine value of the angle, and then you just multiply them together, and then you can get the real number part. And then if you are trying to find which the question is asking you, which one of the answer choices has the greatest real part, we just have to do this with all the other answer choices. So I'm going to make a graph. Okay, so looking at this, we can see that place it into the answer choice A, B, C, D, E, and then the length of the radius, the angle theta, and then the real number part, which is z to the 5th power, it is equal to the radius to the 5th power, and then its cosine of the angle. So how are we going to do this? Well, we know that we already did b, so this is going to be 5 pi over 6, and then 32 times cosine of 25 pi over 6, which simplified down to 32 times cosine of pi over 6, which was equal to 32 times the square root of 3 over 2. Now, we can do this with all the other ones. So for answer choice A is -2. And since if we were going to plug this into this equation right here, answer choice A would just basically be -2 plus 0 times I. So you would go left -2 and then go up 0. So this is just -2. And how did we get to this dot? Well, we know that this is the initial place where we start from. And then if we were trying to rotate all the way over here, we know that this is pi. Because one circle is 2 pi, so half of it is going to be pi. So you basically rotated pi. So the angle right here is going to be pi. And so how do we know what the radius is? Well, we know that since you're going over -2, then this is equal to the radius, which is going to be 2. Now, the same for the next one, which is c. So c is the negative square root of 2 plus the square root of 2i. So you're going left negative square root of 2, and then you're going up square root of 2i. So it would just be right here. Since this is negative square root of 2 and this is square root of 2, then we can use Pythagorean theorem and find that the radius is going to be 2. And then so what is the angle that you rotated for over here? So since we know that these two are equal, then we know this is a 45-degree angle, which is equal to pi over 4. That leaves us with the rest of the angle is going to be 3 pi over 4. Since you always start from this side, we can never use this angle to find how many it rotated because we're starting from this initial side right here. Now for the answer choice D is -1 plus the square root of 3i. So if we're going first over -1 and then we are going up the square root of 3, then this is the square root of 3, so we can see that this part right here, the radius, is still 2. If we're just looking at the triangle in general, like the length of the triangle, this is 1, this is 2, then that means this is a 60-degree angle. So this is going to be pi over 3. So that means this is 2 pi over 3. So it rotated 2 pi over 3, and that is going to be the angle. And then the last one is 2i. So if we're looking at 2i, then that means there is no real part. So there is 0 plus 2i. So we're going right and left 0. So we're just staying at the origin and then going up 2. So to rotate from the initial angle to the y-axis, you go over half of the whole pi. So this is going to be pi over 2. And then the radius is going to be 2. Okay, now that we know what the radius and the angle is, we can see that all of the radius is 2. And then here are the angles for theta. So we can simplify this, and remember when we were plugging in this formula, we use r to the 5th power, and we know that r is 2 for all of them. So 2 to the 5th power is going to be 32 for all of them. The next part is to find cosine of 5 pi. So the cosine of 5 pi is equal to, well, since 2 pi is 1 rotation around, then that means 5 pi is equal to 4 pi plus pi. So we're going over 4 times and then going over pi. Like I said, that is the original one. So this can simplify down to 32 cosine of pi, which equals, well, what is the cosine of pi? You're going over -1. So it is going to be 32 times -1. Now, this is going to be the same concept for the rest of these. So this is going to be cosine of 15 pi over 4. 32 times cosine of 7 pi over 4. 4 times 2 is 8. So one circle around would be 8 pi over 4, which equals 2 pi. So subtract that from this original one and you get 7 pi over 4. So what this angle right here looks like, it is going to be in the unit circle, and then 45 degrees would be pi over 4. So you go over 1, 2, 3, 4, 5, 6, 7. So it is going to be this angle right here, so which is going to be equal to square root of 2 over 2 negative square root of 2 over 2. And then since it is cosine, you're trying to find the x value, which is the square root of 2 over 2. So this would equal 32 times the square root of 2 over 2. Cosine of 2 pi over 3 times 5, that would be 10 pi over 3. And then 2 pi, in this situation, if we were trying to find the common denominator of 3, it would equal 6 pi over 3. If we're subtracting 6 pi, then we get 4 pi over 3. So what this looks like right here, it is going to be 1, 2, 3. This is going to be 3 pi, and then 4 pi, which is, this is a 60-degree angle right here. So that would be -1/2, and then negative the square root of 3 over 2. Since you are trying to find cosine, it is the x value, so that is going to be -1/2. Now, moving on to the last one, we get, here is 32, and then it is going to be cosine of 5 pi over 2, minus one circle, which is 2 pi. We get 32 times cosine of pi over 2, and this is going to be equal, well, we know that cosine of pi over 2, here's pi over 2. So cosine 0, the x value is going to be 0. So this is going to be 32 times 0. Now, right now, we are just trying to find what is the greatest real part. And we have all of this. And we factored out the 32. I didn't factor this in for a reason. It is because it is easier for us to just compare the smaller values right here. So we know that 32 times -1 is going to be a -32, and this is also going to be negative. So these two negatives are obviously going to be smaller than the positive numbers. So we're going to know that these are not going to be it. So it is not going to be D, and it is not going to be A. And now we're just trying to compare these three numbers, the square root of 3 over 2, the square root of 2 over 2, and 0. We know that 0 is smaller than all of these, and then the square root of 2 over 2 is a 45-degree angle, and the square root of 3 over 2, if we put it as sign, it is going to be a 60-degree angle. So that means that B is going to be the largest out of all of them. And obviously, we can use a calculator to also find this out. So the answer is going to be B. Looking at our answer choices, we can see that the answer is going to be B, the negative square root of 3 plus I.